Hey Fabio.
Hey Adam, good to meet you.
Yeah. What was your first computer?
Oh, my first computer. Uh, Interesting question. I guess I used my mom's computer to program Lego Mindstorms.
Oh,
That was the first computer that I used. Yeah,
okay. That's interesting. So the NXT or the newer one?
I think the very first one. I forgot what they called, like the really old one.
Okay.
And I really liked this block-based programming environment. That was so much fun to build this robot that follows a black line.
hmm Yeah, exactly. So this was the very first Mindstorm, right?
Yeah, I think so. Yes.
Then I think it was around 2005, 6, something like this, right?
Yeah, maybe something like that.
Yeah.
Yep.
And you started programming, or you just wanted, to play games, or?
No, I really never was a big fan of programming of games. I always got curious how they work, so I always wanted to build my own games. Never really wanted to play them. And then, yeah, I was excited about the internet, building websites and stuff. That got me hooked too. And yeah, in 2008, I participated in this course for students where we learned how to program in Java. So that got me introduced to Java, and then at university I got introduced to Python, and yeah, now I'm polyglot, I guess.
Oh. What was your reaction to Python if you already knew Java?
Well, I really liked it. Well, I at this time I thought, yeah, Java is like one of your like your first car. Like it drives really well, but doesn't look so good, right?
hmm
And that was Java. I don't know, 1.4, something like that. I don't know. I can't remember. But Python was very different, and I liked not having to think about types all the time, and instead, yeah, run into runtime errors and stuff like that. And the tutor at university was just phenomenal. He was a great teacher. So that was quite an experience and left quite the impression on me.
hmm And how you learn Java? I mean, how you started and why Java? I mean, you started with Lego, not logo,
Lego, yeah.
Lego Mindstorm the block language, and I think there was even Java binding back then. So they all, yeah.
Yeah, I mean, yeah, we used Java in school. There's this awful library. Well, I find it awful, but it was great for teaching, I suppose, which is called Stifte und Mäuse. So this is German. It means
Oh,
pencils and mice, if you will. And it abstracts away like most of the AWT swing stuff and allows you to do things like create a new pencil and tell the pencil to draw something on this canvas and stuff. So that was the level of Java that I was introduced with. And yeah, I never really built like a really large Java application at that time.
okay. And your motivation was the school, right? The Stifte and Mäuse thing. It's not like you wanted to learn Java because you wanted to achieve something.
No. This was purely for school. We got
Okay,
introduced to some basic algorithms and stuff. We used BlueJ as
exactly.
IDE.
NetBeans. hmm
Yeah, yeah.
Yeah, interesting that you did it at school back then. So what I remember, Lejos, Lejos. This was this Lego Java operating system. This is what I wanted to try out whenever I had time. So this was the block language, and I knew back then that Lego also this Mindstorm supports Java. So I think this could be fun, to control the Legos with Java. Okay, so you had to learn Java, and you wanted to learn
Yes.
Python. This is actually the outcome, right?
Well, I had to learn Python too, and it was mandatory for the course. But
Mhm.
I enjoyed that a bit more, I would say. Yes.
I can imagine why. Because it's simpler, right? So you can achieve more in less time. With Python, you
Maybe.
can just start, write a function and you are basically done. And in Java, there you need something, you need at least a little bit Maven or you need some environment. And in Python, you can just write code, right?
Yeah. Well, the first thing that they tell you is like how to set up a big IDE. And whereas in Python you can just create a simple file in whatever editor you want and run it without having to compile it first and then run it and worry about your class path or your module path and things like that, right?
So what was your first interesting program you wrote?
Oh, that's a tough one.
Or not even interesting? So
I built this extension in PHP actually. So I did also some backend development at the time when I started building websites. And then there was this content management system. I think it's called PHP Fusion. But this goes like really, yeah, it's pretty old, I guess. Maybe it's still around. I built this extension for PHP Fusion for sport clubs that let you like showcase your teams and your players. And I'm playing basketball myself, so I built this for my sport club, and then eventually other people got interested, and then it turned into a small business. So I like founded a company and sold that extension to more than 1,000 people, I think. So that was like my first interesting program, I think, that I built.
And was commercially successful.
I guess so. Yes, I guess.
That's actually unusual, right? I mean, that you know, Java, Python, then PHP extension and selling right away. So this actually...
Yeah, I don't think this is like very usual. I was just very curious at the time and really wanted to see what's happening, what's working. And at the time, PHP was the way to go about content management systems. And yeah, that got me hooked. Maybe also around like 2008, 9, 10, something like that.
Because interesting, because back then I did, even right now I do know Java all the time. And back then, in my project, there was basically no PHP. So interesting that you said, this was the way to go.
Yeah, well, I must say, I haven't used PHP ever since I got into university, and I don't miss it. I really don't miss it. Over the time at university, I continue to learn more languages that are even older than PHP, right? So like SmallTalk is one of the things that I'm really passionate about today, and that goes back much longer, I'd say, and has influenced many other languages.
SmallTalk, you say?
Yes. Yeah.
Interesting. This is a recurring theme, and I had the pleasure to work with SmallTalk developers, and it was interesting experience because it was prior to 2008, I'm pretty sure. So there were no lambdas in Javas, and what SmallTalk developers really enjoyed back then was blocks. They always ask me how to do blocks in Java. It's like, why you need blocks? And then I back then I think you could achieve something similar with inner classes. So I showed them the inner classes, and what they immediately did, which was interesting, they had like meta programming inheritance. So they had inner class which inherits from another inner class within an object. So you had an object hierarchy, and inside the object there was an inner class inheritance, and they were then really happy with it. And I said, okay, this is strange for a Java developer, but if you're happy, go with it, right? But it was an interesting system because the SmallTalk developers, they really hated, the unnecessary abstractions and layers, and procedural stuff.
Yes.
So there was a view classes, nice classes, and it was actually a very complex system, but it looked simple. So I really enjoyed the project, actually.
Yeah, well, I got introduced at Hasso-Plattner Institute, which has two mandatory bachelor lectures in the bachelor program where you have to use SmallTalk. It's great because everyone starts from scratch. Sometimes there are people that are familiar with C++ or Python, and then they have to build a game. But then they are much more proficient in that language. So we make students, I say we because I was part of that research group then eventually, we made students, or still make students, use SmallTalk and build a game, and then build some other tool in the software architecture and software engineering lectures as part of the bachelor program. And that completely blew my mind that there's such a thing that has not just a language, but also a whole programming system, and you can change whatever you want in the system. This is like personal computing at its best. And I found that really interesting. And then eventually I had the idea that maybe we can bring some of this programming experience that I know from SmallTalk and enjoy to other languages, which started my master's thesis, where I built my own polyglot VM using rpyhton. That's the PyPy toolchain. So again, I was using Python underneath. And then built my own polyglot VM, built my own interoperability protocol. Well, actually, I just used the SmallTalk meta object protocol. And then I had a SmallTalk programming system that could also do Python and Ruby. And then I realized this doesn't scale so well because I want more languages and I also don't want to build everything on my own. And then I redid the whole experiment and moved to GraalVM. That got me hooked to GraalVM. And here I am today.
But actually, PyPy is similar to GraalVM, right?
In some ways it's not. So GraalVM and PyPy both have a language implementation framework. Actually in PyPy, this is called rpyhton. I guess it's for restricted Python. It's a subset of Python. It feels like you're writing Python with a C mindset. You can't really have different objects from different types in one list. And then there's this rtyper thing that types all of your Python data structures and produces C code, and then you compile it with GCC and get a binary out of it. And the just-in-time compiler that you can get for free deploys meta tracing, whereas in GraalVM, the just-in-time compiler that you get does partial evaluation. So these are conceptually different, but they're also possible to combine. So there's some research on that too.
Mm-hmm. But even in the PyPy case, Python can be cross-compiled, or how to call it, cross-compiled to native image, right?
In the PyPy case, you mean to native image? You mean in GraalVM, we can translate the Graal Python interpreter with native image into a binary, so it doesn't run on the JVM
Python
anymore.
as well, right? There's the same possibility with PyPy, right? There was a possibility with Python, with PyPy, to create a native, how to call it? I know, a native image or execute Python without interpretation, or how to call it, JIT Python.
Yeah, well, that I guess. Well, I've done this myself a bunch of times. You can use the rpython toolchain to produce binaries out of Python code. Yeah.
So how to call it? So what is the right name for it? Because in Java would be native image or JIT maybe, or how to call it?
I'd say it's the rpython toolchain.
Oh, just toolchain. Yeah. Okay.
Yeah.
But
it's part of the PyPy project.
But if you pick an interpreted language and you create an executable image without interpretation, how the process is called? Transpilation?
That's a tricky one. Transpilation is if you're transpiling from one to another language, right? And you could say that machine code is also some other language.
So how you would call it? Because I always wonder, because now if I say, okay, with GraalVM, I just say, and we create native image, fine. I mean, but this is not the name of the process.
Yeah, I guess it depends on the use case, right? I would call, in the native image context, I certainly would call it AOT compilation. I would AOT compile your application as opposed to compile it at runtime. But interpreted versus compiled languages is really an implementation detail of the language implementation, right? You can interpret C, right? And you can run you can compile Java to native image, for instance, right? So you can mix those execution modes if you want.
Yeah, and you are aware of Bean Shell?
Bean Shell, no.
Bean Shell, I think, was interpreted Java. So you could load, Java to a database and load it. You could use Java for configuration purposes or scripting and stuff like that.
Okay, interesting. Well, in Truffle we have Java in Truffle, which
Espresso,
we also call Espresso. Yes, internally. Yes, Espresso.
Yeah. So it was too interesting. Your master thesis. You build your own VM. I mean, how hard is it?
Well, technically, I was building on stuff that other people have already built. And there's this research on interpreter composition, so composing different interpreters by Laurie Trutt and his group at King's College, and that was the missing part that enabled all of this. So the idea that I could combine multiple interpreters within the same VM, which is essentially what GraalVM can do too. And so the only problem was that rpython was not designed, or is still not designed for being polyglot. It's designed to be the language implementation framework for PyPy. And there are some other projects like Topaz, which is a Ruby implementation in rpython. It's not actively maintained anymore, I guess. And there's also rsqueak, which is a Squeak SmallTalk implementation in R that is maintained in our research group at HPI, the research group I was involved with at HPI. So I took rsqueak, PyPy, and Topaz, and combined these interpreters in one. And I had to come up with an execution model. So how do I schedule these interpreters? And I decided to use the SmallTalk scheduler to do this. So every time you execute Python code, for instance, you spawn a new SmallTalk process that represents this Python execution, and it will execute some number of Python bytecodes and then yield back to SmallTalk. And the same happens for Ruby as well. So SmallTalk is completely under control of like other languages being executed. That's that's the execution model that I decided I'd go for. In GraalVM, Java determines the execution model, right? So Java says what to run next, essentially. But because I was under control,
but in GraalVM it doesn't have to be that way, right? You can start with another language, so you can say now the hosted language is C. It could also work to my
the start language if you want, but the host language is Java, right?
You're right. Yeah.
But there's no host language in rpython necessarily. It's all transpiled to C and then compiled into a binary. Yeah, and that allowed me to build a debugger, or not to build a debugger, but to adapt the SmallTalk debugger, so I can step from SmallTalk code directly into like Python code, and even do like edit and continue style debugging in Python, which you usually can't, right?
Which is also possible in Graal. What interests me, your thesis, how to imagine this? You've wrote shell script glue code. You wrote low level C. You checked everything out and tried to compile it. So how you tackle the problem, so how you approach it, and I think so you check all the code bases, try to compile it first. So it's interesting, the process.
The process was actually quite simple. So we have this concept of a master's project at HPI, which every master student has to participate in. And in the project that I did, we experimented with combining AskWeek, or the SmallTalk implementation in rpython, with a SQL hybrid implementation. So you can do like SmallTalk and MySQL, for instance, or some SQL, SQLite actually, and the whole purpose of this was to experiment with just-in-time compilation and to see whether we can optimize across these languages, right? If you will, SQL is just a data language, so this is already polyglot. So because I saw this was possible, I thought maybe we can do this with another programming language. And the way we did this was with an VM-level plugin. So essentially, I extended AskWeek with a SmallTalk VM plugin. So the AskWeek is a SmallTalk VM, and SmallTalk VM support these plugins, and I added support for Python and the Ruby plugin, and the Python and the Ruby plugin, they actually know how to spawn a new interpreter loop from PyPy or from Topaz. So that's how it works. Yes, and when you compile this, and that was actually quite funny. AskWeek to compile takes like 15 minutes on my machine back then, and compiling PyPy takes like an hour, and Topaz was maybe 10 minutes. So compiling all of this would actually take 1.5 hours and even more. So this was a really bad turnaround, and that caused some frustration as well, especially when you have to debug something like a segfault and you have to rebuild everything.
So is something like this doable for I would say, how to call it, a mid-range programmer, maybe, someone who understands the concept but is not like, deep into programming? Because I still don't understand how much you have to know how everything works,
So I guess when
crazy what you did, or how much time did you spend with that? So it's like, full-time job, or you spend, nights just thinking about this, or what is the process of that?
Yeah, I guess I did all of this in like maybe 6 or 8 months, but I not without the help of others, right? I mean, of course I did the implementation myself, but when I started in my master's and I took the first seminar on virtual machines at HPI, I was a completely noob, and that got me introduced to GraalVM. We worked on Truffle Ruby and did an implementation, a new optimization for Truffle Ruby back then with Chris Seaton. And it completely blew my mind because I didn't understand what was going on. Like, I saw that this benchmark runs in the first 10 iterations really, really slow, and then gets insanely fast. And I was like, it doesn't make I don't understand how all of this works. So, and again, you remember I said I was curious about like how does Lego Minecraft mindstorms work and all these things, right? And Python, and how do I build backends? So I was like, I want to understand how this works. So at that time, I don't even think things like native image were public. And GraalVM was somewhat open source, but not all of it. So, and of course there was no SmallTalk implementation. So the VM lecture that I took was, I worked on this Ask Week VM as part of a student project there, and that introduced me to a bunch of concepts like polymorphic inline caches and all these basic VM stuff. But then I also saw how to implement languages, how to build an interpreter loop, how SmallTalk works, how block closures work, how they are activated and stuff. And then eventually, I did this experiment, and it turned out better than we initially thought. And then, an obvious thing was to bring the whole experience to GraalVM, and that, it let me, build Truffle Squeak, which is now my the SmallTalk implementation that I primarily built in Truffle.
Okay. How were your grades at school?
I guess I did a little bit above average, let's say. Yeah, it was. I think I did put a bit more work into than average, and got something good out of it too.
Okay, so this is my question. So you actually had to learn at school, right? So it's not
but the thing is, if it's something that you really want to learn, then it's really, really easy.
Exactly.
Of course, when I was younger, I was like, okay, I forgot about the time, and then all of a sudden it was 10 p.m. and I was like, okay, maybe I should go home now. This has changed. But if I do remember, we had these other lectures that were mandatory as part of my bachelor's that I didn't enjoy as much, and that was painful because I still needed to learn something, but it wasn't something that I was interested in. Whereas with VMs, I was like, this is so cool, this is so much fun, and I got so much support from so many people, and they were like, hey, can you try this, can you do that? And when I had a problem, I was like, can someone help me? And they were like, yeah, sure, this is how you do it. And that was easier than I thought.
Okay, that's fine. So you are good at school because you invest some time, right? So this was the entire,
yes.
And you okay, this is normal. Because I thought, it's all interesting if someone, does something which is incredible. I always ask myself, this is just work, luck, or maybe, talent. And what I see more and more, actually, at the end of the day is work. Whatever you do, you have actually to spend time with the stuff.
Yes.
Otherwise, you will never become good.
Yeah. Well, I'm not sure how much you know about the Hasso-Plattner Institute, but the students there are generally really, really motivated and great, and they turn out to be great engineers in the end.
Is it in Waldorf?
No, it's not in Waldorf. It's actually in Potsdam. So
okay.
Hasso-Plattner lives has a house in Potsdam too, and he really likes the city. Initially, thought maybe. Well, he wants to support education, so maybe he can build something like the Hasso-Plattner University. And then he realized there's already a university, really big university in Potsdam. And then he built an institute that belongs to the university. And I think 4 or 5 years ago, HPI turned into a whole faculty. So not even just one track, but now they're running 4, maybe even 5 tracks today. Yeah.
So I was at SAP, I think, around 2003, but just to deliver some courses to teach the how's called the language ABAP developers.
ABAP,
Java.
yes.
ABAP, yeah. Yep. And I met some skilled developers who actually implemented the SAP VM for ABAP back then.
Oh, cool.
And some of them worked, I think, with Hasso-Plattner even. So as to my knowledge, Hasso-Plattner started with the implementation of the ABAP VM in a garage. This is what and it is interesting, that yeah.
Well, he has his own research chair or research group, and I think in this group they experimented with one of the first prototypes that turned into HANA. Eventually.
Okay. The NoSQL database.
Yes. Yeah.
Okay, so now the question. Default was mindstorms. This is
mindstorms. Yes.
Yeah, this is the problem, right? And then from then everything was fun, and you had to understand how everything is working. How you found GraalVM?
Yeah, well, great. Otherwise, I wouldn't still working with it, right? I mean,
But how? I mean, because you spend time on
how I discovered it.
Yeah.
Well, I guess GraalVM is still very much not only a product but also a research project, and there's no way you don't see a GraalVM engineer at one of these VM conferences. They are also organizing some of the workshops. There was a truffle workshop at the European Conference for Object-Oriented Programming, ECUB, in Berlin earlier this year, and they're very active. So there's also other communities like Facebook is working on some Python optimizations, and there's JavaScript core from Apple. So the research community is quite big, but the people, they know each other really well, and that's how I was introduced to GraalVM and saw how things work.
Okay, because I think similar force is also in .NET land, right? So we could also do some similar stuff in .NET.
Yes. Well, it's not focusing on this polyglot aspect anymore. They do have something like a native image equivalent now, I think.
Yeah.
But I haven't had the time to really look into it that much.
Yeah. Okay. So when was it with GraalVM?
Oh, good question. When did I start with my master? Maybe 6-7 years ago.
Okay, and now you're working full time on GraalVM.
Yes, I'm part of the GraalVM team, working on everything that has to do with tools, the programming languages, and generally trying to improve the developer experience. I would consider myself a tools person, I think we've made great progress in the recent releases, especially with the new one too, and there's definitely more to come. So I'm super excited to be part of the project. It's also really rare. I mean, I not only did my master's but also did a PhD afterwards, right? And it's very
what is the topic of your PhD then?
I said truffle squeak, right? That was my PhD project, more or less.
Okay.
So the idea is to use this. The idea of a self-sustaining programming system on top of a polyglot VM, and then things are really close because you have.
What means self-sustaining? What means self-sustaining?
Right. So self-sustaining means it is written in itself and it can sustain itself. So
bootstrap itself, right?
Yeah, it can bootstrap itself. They are you could say that PyPy is also a self-sustaining system, like a compiler that you bootstrap. But a self-sustaining programming system like SmallTalk, or there's Lively Kernel, there's also Self, right, which came out of SmallTalk too. And these allow you to develop from within. You can actually build a whole application in a debugger, and that makes them really productive. And usually when you build tools like external tools based on dynamic runtime information, like a debugger, you have to go through some tool interface like JVMTI or JWDP, or GraalVM has the different tooling interfaces too. And they make for really poor exploration. Like if I want to explore a whole new idea, I want to explore data structure that is somewhere in the compiler, is really hard to open that up. It's not open for good reasons, but if you want to just experiment and see what you can do with it, then this is really bad for experimentation. So the idea was to bring a whole programming system on top of a polyglot VM, and allowing with introspection to look into compiler components, look into other languages, look into other language implementations, and explore what's possible within these systems. So and that's exactly what my PhD thesis was about: an exploratory tool building platform for polyglot virtual machines. That's the title of the thesis.
Yeah. I mean, if you think about this, right, sometimes it is interesting because it's almost recursive, right? So you have to say, okay, where I am right now. So you have, to keep what is the focus? Because if you lose the focus, everything is flexible. It's just possible. And it is more almost like quantum physics in software engineering, right?
Yes, it is very much like that. Yeah. And meta seriality on different levels can be very confusing. Yes.
Okay, what you did in GraalVM, so the last 7 years, you also always did this with the tooling and developer, how to call it, evangelism or not evangelism?
Well,
What?
I started last year in September in the GraalVM team. So I'm one of the newer team members of the group. I knew some of them before, most of them before, because I also served on the advisory board as a representative of, I guess, Truffle Squeak and the academic community in some way. And so what I was trying to say a couple of minutes ago, but didn't get to it, was that it's kind of rare that after you're done with your PhD, you continue working on the same project. And it's actually great because I was productive from the very start, right? I didn't need big introduction to people. I didn't need to familiarize myself with the technology. And I guess one of the things that I did with Thomas Wittinger was this stream on Twitch on how to use Truffle Squeak and what you can do with it. And he played around with it a lot, and that was a lot of fun. And then when I joined, he was like, I have an idea for you, a starter project. I also wanted to look more into native image, so he proposed that we need to do something about the build output, right? What you see when you build a native executable using native image. So that was my starter project, and I explored what are customers looking at, what are users most interested in, then designed this with the community, wrote an RFC that we put up on GitHub, and then implemented all of this. And this actually got merged in, I think, 22.0 or 22.1, I think 22.0. So that was relatively quick. Again, I was supported by a lot of people, and that's the type of thing that I like, and I think there's still some low-hanging fruit within the GraalVM project where customers have obvious questions, and we need to provide better tools or the appropriate tools to answer these. Like, what's inside of my native executable, right? What Java classes and objects ended up in this binary, for instance.
Feedback to the output is way better, and not only everyone noticed that. Actually, everyone who upgraded to the new GraalVM, so I get a feedback, hey, now it's completely different, it's more useful. So a good job there.
Yeah. Thanks.
And so I have because GraalVM is actually huge. So the Java developers, if you tell them GraalVM, everyone only sees the native image.
Mm-hmm.
So for me, not that much. It has something with cloud economics. So usually I use GraalVM for different purposes. For instance, what I did a lot, I integrated JavaScript with Java, just to have, because I needed some template libraries. I was too lazy to implement it with Java, so I just picked JavaScript and it just worked. I could how to call it now, AOT it, right?
Yes.
But I hadn't, because this interpreted was fast enough. And now I'm also experimenting, because I have actually to call via JNI some native code, and this becomes interesting, because it seems like GraalVM has several possibilities to do that. So one is, you could actually load C like language, or LLVM language, at least is my understanding, to GraalVM and treat it almost like JavaScript. So what I did with JavaScript, I could actually partially do the same with C.
Yes.
So
yes.
Yeah, which is crazy already, because I had a lot of experience with JavaScript, right? So it just passed Java parameters back and forth, and I started with C, and it worked exactly the same way. I said, okay, this is really sure.
We call this we call this embedding. So you embed one of the GraalVM languages into your Java application. Yeah.
That is, what's not obvious then, and how to pass parameters which are not primitive parameters, and it starts with string, right? Because if you start with string, they look a little bit there is like a C string, I think it's called. So you provide additional API, but this is where it is no more that obvious. I will do some investigation next time, because I would really like to understand, what's going on. What I also looked, what JNI is doing, was also interesting, because this Java ships with JNI.h. So again, you have the same problem what they are doing. and they have the JString, which looks just like a data structure. And I know where the problem lies, because in C there is no string, right? They have just a character erasers that there has to be some part of transformation. But let's say, what is the strategy in the embedding case? I would like to call existing C library with some parameters. What I actually have to do, or what is the best practice, or whatever. I think I understand I shouldn't pass it per reference, because this is where the problems with garbage collector may start. So there should be per value, but I have to map the data structure somehow. What I saw, what always happens, struct, right? So you always start with a struct.
Yeah. Well, first of all, I should say that we already talked about all the things that I've done as part of my PhD and my master thesis and so forth. And one of the things that I didn't look into that much is composing languages with GraalVM languages with C and C++ on top of LLVM, because you have an additional abstraction, the LLVM IR, and that makes everything a bit more problematic. So you can polyglot evaluate LLVM IR, but who writes that, right? You write C code, and then you compile that to LLVM IR and run it. And I didn't look into that much. So I don't actually really know how to do this particular task, and I would probably look at the GraalVM docs, and I'm sure they have an example, and if they don't, file an issue, and we'll fix the docs. Okay. There is some experimentation done by Kevin Minard, who is now at Shopify, and he worked on he's working still on Truffle Ruby. And he wrote a blog post, very extensive blog post, how you can embed truffle languages on different levels using JNI. So he can I think call out from a C or C++ application into Truffle Ruby native. So like AOT compiled Truffle Ruby. So maybe that's also of interest to you how he does that, because he needs to pass non-primitive objects across these boundaries.
Because we get nicer JNI integration in Java 19, and what I found similar concepts in GraalVM, that this is interesting and this is already available. And this embedding, what I meant is from Java to C. This is the most common part, to find alternatives to plain JNI, yes. Because GraalVM also supports JNI, so I could just use straight JNI, and this seems to be supported.
Yeah, there's even another thing for native access, which is the native function interface in Truffle NFI, which Truffle languages underneath use to implement foreign function interfaces, for instance.
Oh, how this looks like? So what you know it out? So what to do to call it? Also, is this like a reflection function, like call this in C, or how this works? Or
no, you can generate. It's a meta language, an internal language, so it's not accessible via polyglot evaluate. I'm sure you can find a way how to still use it, and it allows you. It has its own syntax. It allows you to load a shared library and then create bindings, and then execute them using the interoperability interface. And then you don't need LLVM or something in between. You're calling out the native code from within Truffle languages.
And there's also another way, which is a little bit hidden, but there is the C API. I don't know how to call it. There's it looks differently, so you can actually load a shared library, which was compiled with LLI. No, LLI is the interpreter with CLang.
Could be, yeah. So I don't know how many ways there are to do interaction between Java and C, but GraalVM supports them all and even more. So check out the docs. If you're missing something, feel free to reach out either on GitHub or on Slack, and I'm sure we'll help you.
Yeah, I would do it. I was just curious. What I found is what I was aware with JavaScript about the embedding. Because this was the replacement of NAS1, right? What NAS1 did with what GraalVM also does similarly. It's a very similar interface. And I was stunned that you can do the same with C-like languages as well.
Yeah.
And then I started to look, okay, this is interesting. And then I found more and more how you can embed, and LLVM languages. And what is also interesting, I think, I would just do it for fun. I think you could even call Swift. because Swift is also Apple language, and this is LLVM, and Swift is open source. This is well integrated to Visual Studio Code, so it should be actually possible, to invoke some Swift functions.
I think so. I haven't seen anyone doing it, but I know I've seen people doing this with Rust and Go, and that works too. So check that out. Yeah.
Yeah, cool.
Well, so we're even using this. We're even using this ourselves in VisualVM. VisualVM has this heap dump explorer, and you can type in some query language, but you can also use JavaScript to analyze your heap. And for that, we're using GraalJS underneath.
Ah, very good. So, what are you doing right now? So, what is your area of of action in the in the huge GraalVM universe?
Yeah, I'm guessing I'm helping out with tools in general. So we have a tooling.
Which
team.
Tools exactly?
Yeah, we have a tooling team in Prague, and they have been working on this GraalVM extension for VisualVM. And that allows you to install GraalVM and use polyglot languages, debug across languages, and also do Java development. We have this GraalVM dashboard, and we really need to move this forward. It could be a lot better, so we're looking into ways how to improve it. And that's for GraalVM native image, and we have these native build tools. That we are, these are plugins for Maven and Gradle that allow you to use a native image, and now including this new metadata repository that you might have seen in our release. And so all I'm saying is that we have lots of different tools, including even starting with things as simple as how do I download GraalVM? And and it turns out with tools are always cross-cutting. So you need someone who knows how to build tools, but you also need someone who knows what to build these tools for, right? Like native image. And at the same time, tools are also very user-centered. So you need some sort of user feedback. You need to establish that. So that's why I'm guessing part of the DevRel team to close that gap and to build this bridge from users back into our tooling teams. To find out what users really need. So one of the things that, again, low-hanging fruit, right? One of the things I realized was it's kind of hard to use GraalVM on GitHub Actions. So I fortunately had experience with building a GitHub Action myself. So so we decided that we need set up GraalVM action that allows users to quickly build native images on GitHub Actions for free on GitHub, right? So we built that, and that has been quite successful, I think.
And it works very well. I didn't know that you are again behind this thing, so I'm using it actually right now.
Cool.
And for Quarkus, and we are AOTing this Quarkus to Linux, Mac, and Windows.
Cool. So you're targeting all three supported platforms.
Yeah, we have to. And Linux is not that important, but we do it anyway. But it was really easy to set up, and it worked right away. So nice. I saw the GitHub action, and I think, okay, probably it comes from Oracle. I had some experience in the past with tooling. I say, I will build it by myself, but let's try, because there's no. What I usually do, I rent a larger machine, EC2 or similar, and just run the GraalVM. And it's not that hard, and it just works, right? And but it worked right away, so there was no excuse, and it was perfect. So
there's not much that this extension needs to do, right? It only needs to know how to download GraalVM, and then sets up your Java in GraalVM home, and then maybe does some additional work for setting up a Windows build environment, which is necessary on Windows, but that is pretty much it, right? There's a couple of more things this thing can do, but it's a relatively easy job. And but it was a missing piece that lots of people are now using to build native executables on GitHub Actions. And you may have seen in the new release that came out on Tuesday, the GraalVM 22.2 release, we have improved the robustness of native image. so that it no longer fails with an out of memory exception if you're running on a system with restricted memory resources. So lots of users run native image in Docker images, and they use 2 gigabytes or provide 2 gigabytes, which is not that much, but now we can build something like Pet Clinic on a machine with only 2 gigabytes, which is kind of cool. And that also means, considering that GitHub Actions provides you with at least 7 gigabytes, I think on macOS it's actually 14, and you can build really big apps on GitHub Actions now, which is really, really cool.
Yeah, there was one challenge with the GitHub Actions, but you can. This is like how to call it, flow by design, and the flow by design is we have 3 different platforms, and the script, or how to call it, the variable substitution and the syntax is different. So you have to know it in advance, because on Windows, if you use the Windows action, some of the variables. I wanted to do more, like upload the image somewhere and stuff like that. And of course, you have to keep in mind that on Mac you get the Mac syntax, and on Linux the Linux syntax, and on Windows the Windows syntax. So
well, there are some tricks. You can use instead of PowerShell, use Bash on Windows too, and then you can run your Bash in Cygwin, I guess. The README has a Hello World that builds on all 4 platforms with the same command. So maybe take another look. There are some tricks that you can do with GitHub Actions to make this more compatible across different platforms. But if you have ideas how to improve it, let us know. Right?
No, this is not a criticism. This was more like, if you start with GitHub Actions, right? So the expectation is, okay, it runs somewhere on Linux, which is not entirely true, because you get 3 processes which run on different operating systems, and this was not obvious for me.
Well, not by default, right? You define where your job runs, right? Whether it runs on Linux, macOS, but if you decide to go for a metrics and run on 3 platforms at the same time, of course,
exactly,
you need to make sure that your things are working on the right system in the right shell.
You have to think about this, right?
Yes,
you have to think about it, because this is okay. Now of course it's obvious, because it's okay. Why Windows and Linux, Mac and Linux are running and Windows fails? It's impossible. And then I say, okay, why? Because you cannot find the file. So why not? Okay, of course it runs on Windows, right? So
and when you do this, then you run into new problems, because some things in Java are in fact platform dependent, and well, at least implemented, right? AWT and Swing, for instance, come to mind. And here you really need to provide different configurations per platform, and that is a bit tricky, but it's also doable.
Yeah, sure. You have just to know it, just to keep in mind.
Yeah.
And so back to the tooling. So in the GraalVM, so what is the killer use case or feature of the GraalVM tooling for Visual Studio Code? Or not even a killer feature. Maybe the listeners don't know about that. So why we should use it?
Yeah. Well, first of all, the extension helps you to set up GraalVM in your IDE, which is kind of nice to have. And it also integrates with all the different components that you can install. I really, really like the debugging support, not only for Polyglot, but also even just for single languages. So, for instance, in Python, I guess debugging is usually done through some sort of, I don't really know how Microsoft does debugging with their Python extension, but we can do debugging with the debug adapter protocol. And not just for Python, but also for all other languages like R and Ruby. And these languages usually provide very different debugging experiences, right? So by default, it's usually an interactive shell, like in Ruby on Python, the PDB. And that I very much like, because you more or less get the same user experience for all different languages. So it not only looks the same, but it also behaves more or less the same. With more or less, I only mean the difference is, of course, the language then, but it's not your tool. Your tool doesn't look different, right? And that I very much like. Also, the ability to debug native executables from GraalVM native image is really, really cool. Lots of people are building native executables now, but of course, when you deploy them, you still want to be able to debug them if a problem happens. And of course, we can't guarantee that everything is 100% correct. After all, in your executable, there's a new garbage collector from Substrate VM and other components, and maybe there's issues in there too, right? So we need to be able to debug all of this. And we can answer that. We can do source level debugging. So you can see Java sources. Also, you're debugging a native executable. And that is really kind of neat. And we are bringing that experience together with JetBrains to IntelliJ very soon. It is already there under preview. And Red Hat is helping a lot too with extending the debugging functionalities in the first place. So I think this is really good work, and demonstrates what we can do with native image even further.
Mm-hmm. So we have the GraalVM extension, and then you mentioned a dashboard.
Yes,
the GraalVM dashboard.
Yeah.
What is the dashboard?
Yeah, the GraalVM dashboard is this thing where you run your native image build and you provide an additional flag, like something with dashboard. You can find it if you go to graalvm.org/dashboard. And then you get additional files depending on what kind of flags you set. And then you can open these files on this website, and it will show you a heap breakdown and a code breakdown and a points to Explorer. These are supposed to help you find like classes that are not supposed to be in your image, or like really big objects that ended up in your image and have bloated that, and also allow you to understand like how methods calling each other inside of the binary. But like I said before, this tool still has lots of potential to be improved, and we are actively working on that in the background. I don't really know where this is heading, but with the new build output, for instance, we are already answering some of these questions. Like you get these little breakdowns for code and image heap right in your build output every time you run. You don't need to rerun and open this file. It also looks kind of weird because it looks like you're uploading the file, but it's really only happening on the client. But yeah, we're still experimenting, maybe making this a bit more of a public API so that the file format is well documented, and then people can analyze their data in whatever way they want with like Jupyter Notebooks or RStudio or something. So we are looking into this as well. Right.
Yeah. And then you mentioned the reachability metadata, right? This was the project you mentioned.
Yes, this is the new big thing that we announced as part of the 22.2 release, together with Spring, Micronaut, and the Quarkus teams. We have built this new metadata repository, which you can find on GitHub under, I think, Oracle/GraalVM reachability-metadata. And
exactly.
Usually you don't, as a user, you wouldn't really use that or interact with that directly unless you want to contribute something. But before we talk about like why you would want to contribute, let's talk about why you would want to consume that and how you can consume that. That's actually through our native build tools. So I already mentioned those, the Gradle and the Maven plugin. If you're using them to build native executables with native image, you can now set a new option in your either Gradle or Maven config that enables the use of this metadata repository. And that means when you build, Maven or Gradle will check your dependencies against the dependencies supported in this metadata repository. And then it will, if it finds a match, it will pull the config for you. And that means it will, with metadata, we really mean the configuration in terms of reflection, resources, and so forth that are sometimes missing when you're building native executables. So that means if we find something for you, or the toolchain finds it for you, then the build will include them, and that makes more code just work with native image, right? And we started with only a few libraries, but I think really important ones like database connectors for MySQL or Postgres. So if you're using those or have been using those and they didn't work for you, try again, use the native build tools. They will pull the stuff for the metadata for you from this repository behind the curtain, and then your native image or your native executables are likely going to work. And of course, if that's still not working because you're using some other dependency that is not yet well supported with native image, you can now also contribute your configuration files to that repository. And then others will benefit from what you've done too, right? So this is a great place for sharing metadata. I should say that this is intended to retrofit metadata for libraries that have already been published, and also to share configurations for libraries that are not supporting native image yet. But the best solution for native image users is that the library or framework has first-class support for native image itself. So Micronaut, Spring, and so forth, they're also providing appropriate metadata from within their jars. So you don't need this metadata repository if you're using a library that is, if you will, supporting native image in a first class way. So that's the best way that library and framework maintainers can support native image within their framework. And then as an intermediate solution, we have this sharing ability now with this reachability metadata repository. And the last resort is that the user needs to provide configuration manually, and we can support those users with the tracing agent too. So you may have seen this tracing agent on the GraalVM website.
I'm taking a look at the reflect config JSON for Postgres, and this is not actually that bad. This is like 100 lines of JSON, and there's this type reachable, and there's no DPG connection, for instance, from where. So this is actually, interesting project. Sounds really useful, because right now we have Postgres, JLine, and H2, we have Tomcat. So this reminds me, I don't know whether you are aware of it, there was in TypeScripts, strongly typed, I think. Definitely typed. There was a similar repository with different backgrounds. So it was not like reachability, but they wanted to have, the type annotations.
Annotations for JavaScript projects. In some way, this is very similar, but for a very different purpose, right? This is for helping developers use JavaScript libraries from within TypeScript, and here we are enriching metadata, or collecting metadata that helps the reachability analysis. Right, the main problem are the mechanisms, the dynamic mechanisms of Java, like reflection, that are extending reachability but are not accessible, or it's really hard to determine what's actually going on in using static analysis, which native image deploys, right, as part of this points to analysis. So it builds up this universe, builds up this world of the things that you really need. And then that's also why the binaries, they turn out very, very small, because it only includes what it really needs to make up your Java application. But if you're using something reflectively, in the worst case, you can even concatenate strings and then end up with a new class name. Then there's no way the static analysis can find this out. So you need to tell it this class is also reachable reflectively, or used by JNI, accessed by JNI, or is using these resources and stuff like that. Yeah.
The process of making the output smaller is called in JavaScript tree shaking. You are also calling this tree shaking in GraalVM, or? I'm not 100% sure how tree shaking works, but I guess you start out with a tree and then you shake it and then you remove things that you don't need, right? But in native image, we're actually tracing through your application and finding all possible code paths. So you don't start out with like a full tree. We are scanning through your code and try to find the things that are really, really only needed or reachable in that sense, and nothing else. So if you have a method that is not used, it will not be part of your application at all. And if the analysis has proven that a method is there and it's technically, potentially it could be reachable, but as part of the application it never will be reachable, then maybe even the compiler can eliminate that. So we have different levels where we can optimize all of this. But I don't think we call it tree shaking, no. So there is no tree shaking required, because you are following the references and you know exactly what is needed. So there is nothing to shake.
Yeah, so it's more like a garbage collector, right? We are trying to find everything, and we make sure that we're not including the garbage in your binary.
Hey, this is not tree shaking. There's like smart fruits, right? So you just say the fruits come to me and it's over.
Yeah. We essentially just mark your application and then compile it.
Is there any tools we forgot to talk about which are interesting or could be interesting to our listeners?
Well, AWT is a thing that comes up in native image a lot. It's not really a tool, but people talk about that too, and we are hopefully improving that very soon.
AWT
support in Linux and on macOS. It's already working quite well on.
What do you mean by AWT now? Because it is abstract window toolkit.
Yeah. That's what I meant. But I was just thinking about stuff that we are working on now in terms of tools. That always shows up because, well, some tools have UIs, right? And we want to eventually use AWT maybe at some point too. Well, one of the things that we have already merged is, you already know the build output, but we are also going to provide an option that allows you to export what you see in the build output as a JSON file, including a JSON schema. So this is considered at some point public API. So that means you can build other tools that consume this JSON, for instance, that allow you to track your numbers of reachable methods or the binary size of your executable, right? So one thing is that you have a certain snapshot of your code base, you run the native image, and then you want to understand why is something inside. Right, and that can be potentially hard, and that's a thing that we're trying to do with this GraalVM dashboard. But with this build output, you can track it over time as part of your GitHub project, for instance, or GitHub repository, and then you would see, okay, I just updated this third-party library, and all of a sudden my binary size exploded. And then you know why this is happening as part of your process. So you can do continuous native image build tracking, if you will, right? And that is something that this JSON output now enables, and I'm sure will provide some additional tooling on top of that.
This is really useful because it's a part of the CI/CD process,
Yes.
And if you on every commit you can track the differences, and if something goes wrong, you can say, okay, I added this Maven dependency, and this caused, this issue. So you can track down easier what's going on. This is, I think, really, really useful.
Yeah. So if you have a look at the public Slack on GraalVM, there's now a discussion, or not a discussion, but some posts from our Quacos friends, and they are reporting that they ran some of their Quacos benchmarks and realized, the robustness has improved indeed, and memory consumption has gone down even further in terms of native image. But they also have these cool graphs, and they're using this JSON integration, I think, at some point too, to build all of this. And we want to allow more users to take advantage of that and make it part of their CI/CD pipelines. Yes.
Really interesting. All my projects are Quarkus right now. So Quarkus takes over the world. So it's getting more and more popular. It's interesting.
Yeah.
Okay, perfect. It was really nice to talk with you. Where people can find you on the internet?
Well, I guess I'm on Twitter most of the time too. My handle is @fniephaus. So that's my the first character of my first name and my last name. But if you search for Fabio GraalVM on Google, I'm sure you'll find me. I'm also on GitHub, of course. I'm on the public Slack, and I'm on LinkedIn. But primarily I hang out on Twitter, I guess.
Okay, so you are the GraalVM Fabio.
Yeah, fortunately, there's not more Fabios in the GraalVM team. We do have lots of Christians, though. So.
Okay. So it was really fun to talk with you.
Yeah, same here. Thanks for the invitation, Adam. Yeah, see you next time. Take care.